Aloha and welcome. We're going to be continuing in our chapter on cloud security with a section here on containers, serverless, and microservices architectures. So we're going to start off with containers. So you may have heard of containers, you may not have, but containers are packages of software that have all the necessary elements to run an application. It includes the code, it includes the libraries, the system tools, and the configurations. So what a container does is it decouples, it separates an application from the underlying hardware. So a container, it can run on any environment. For example, virtual machines, physical servers, on-premise data centers, and public clouds. So in order to run this container, we need something called a container engine. And a container engine is a program that manages the execution of containers. You've probably heard of Dockers or Kubernetes, things like this. Those are container engines. So unlike a virtual machine it virtualizes the hardware. The container is actually going to virtualize the operating system. So compared to a virtual machine, a container is going to be lightweight, it's going to be efficient because the container does not need to boot an operating system or load any libraries. So the container is defined for a specific operating system. So keep that in mind. For example, a containerized Windows application can only run on Windows. So you need to keep that in mind when you're building these things. We have a participation activity that's going to show you a lot of the differences between hardware virtualization and operating system virtualization using containers. Do take a look at that. We also want to talk about serverless and microservices architecture. So these things were pretty big. They were blowing up right before the pandemic, a couple of years before the pandemic. Everybody was talking about serverless. Everybody's talking about microservices. So let's talk about that. So containers, they support modern development and application patterns such as serverless and microservice architectures. So serverless, also known as serverless architecture, it's a cloud computing model that automatically provisions and scales computing resources. So serverless architecture delegates all the management responsibilities such as provisioning, scheduling, and scaling of the cloud infrastructure to the cloud provider. So for example, if you're using AWS, Amazon Web Services, they've got AWS Lambda. Microsoft has Microsoft Azure Functions. Google Cloud has Google Cloud Functions. These are all serverless cloud services. Then we've got microservices. Microservices, also known as microservices architecture, that's a software design approach that breaks up an application, one monolithic large application into smaller independently deployable components or services. So microservices have a technology stack inclusive of database and data models, and they communicate to each other using APIs, application program interfaces. So microservices, they enable automated, iterative, deliberative delivery methodologies such as continuing integration, continuous deployment, the CI/CD for in DevOps that we mentioned in one of the previous chapters. So that's what microservices are used for. If you've broken it up into multiple microservices, it makes it easier to work on any one section of that. So microservices are typically deployed inside containers and are used in real-time data processing applications. So when you think about real-time, you're thinking about where time is critical. So air traffic controllers is an example. E-banking systems that operate in real time, they benefit from these highly available, lightweight, scalable microservices. There's a lot of debate now. So microservices went through its heyday several years ago. Everybody was trying to, take their large monolithic systems and break them into microservices. There's been some backlash in that, as well as in serverless. There's been some backlash, and if you've got time, take a look into that on your own. See what's happened historically between these paradigms. You'll see that maybe people are moving away from those. So they're still out there, but a lot of people have invested into creating their software apps, their large software applications, breaking them up into microservices, only to find later on that it's inefficient and they're really dependent upon to be quite honest, cloud service providers out there, and that gets to be cost ineffective for them at some point. So there have been some companies that reverse back from that. So that's beyond the scope of what we're talking about here, but that's just something to keep in mind as you're reviewing these. There's also the concept of platform diversity. So platform diversity, it refers to the strategic development of different application components across a variety of execution environments optimized for specific tasks. So you're choosing the specific environment that does the specific task you're doing, the best. So container platforms, they provide scalability and isolation. Serverless architecture offers cost efficiency and dynamic scaling. And microservices, they offer diverse infrastructures and uh, they enhance performance and resilience. So deploying each application component in the most suitable environment improves the system efficiency, reduces platform-specific vulnerabilities, and leads to more robust and reliable applications. So this could be cost effective. It might not be. It could also be complicating things if you have a team that has to now be versed in multiple technologies. So there's always trade-offs in these things. But for the sake of our readings here, just know that platform diversity, what the benefits of it are. And that is it. We've talked about containers. We've talked about container engines that host the containers. We've talked about the difference between the virtualizing the hardware versus virtualizing the operating system and using containers. We've talked about other architectures like serverless architectures and microservices architectures. And then we followed it up with the idea of platform diversity using the proper technology for the proper fit for what we're doing. So that's it for this section. I hope you enjoyed it, and I'll see you in the next one. Aloha.